In this video I'm going to give a brief explanation of why nanotechnology has its own field. So in my previous video, what is nanotechnology and what is nano, which I'll put a link in up above, I defined nanotechnology as anything where we are interested in matter which has dimensions which are between 1 nanometer and 100 nanometers. So this means that any of its dimensions can be within that range. So it may have one dimension within that range, or it might have all 3 dimensions in that range. The question is, why is this range important, and why are so many people obsessed with this idea of nanotechnology? What's so special about it? Why doesn't microtechnology have the same effect? Why doesn't picotechnology have the same effect? And the answer is actually quite varied. So, when we start getting down to 100 nanometer scales and smaller, we start experiencing different elements of physics. So, when we are less than 100 nanometers in size, we are starting to get to the point where we are much smaller than the wavelength of light, which means that we can't actually visibly see nanostructures. So we have to develop new technologies to be able to look at them. So things like scanning electron microscope, scanning tunneling microscopes, atomic force microscopes. So there's an element of nanotechnology which involves just the instrumentation to be able to study this field. We also have the boundary points in physics starting to come to fruition. So at a large scale, such as the scale of a human, gravity is a very dominant force. However, when we start getting down to the nanoscale, what's known as the surface area to volume ratio starts getting larger. So that means that the amount of surface area per volume is much, much greater. And again, I'll do another video which really explains this, but hopefully, as you'll see from this little image here of a cube being split down into smaller cubes, how much extra surface area there is when you have lots of small fins compared to one big fin. And surface area starts having a large effect, because if you think from a chemical point of view, chemistry or chemical reactions happen on the surface. So therefore there can be a lot more chemical reactions happening in nanostructures, and in chemistry it's all about chance. So the more nanostructures you have, or the more surface area you have, the more likelihood there is of a reaction. From a more physics point of view, friction is heavily dependent on surface area. So when we get down to these nanoscales, effects such as friction become huge compared to sort of gravity. So imagine if you had a slope and you were trying to slide something down it. Something of big volume will slide down fairly easily because gravity can pull it. However, when you get down to the nanoscale, because of that increased friction, gravity can't overcome it, so things get stuck. We also get the boundary into quantum mechanics. So again, I'll do a video trying to explain quantum mechanics. But when we start talking about quantum mechanics, we're talking about atom-like behaviour. So atoms are around 1/10 of a nanometer in size. So if we got something which are a few nanometers in size, we have very few atoms making that material up. So instead of acting like a bulk material, we start getting atom-like behaviour. So imagine an atom with shells of electrons which are in discrete energy levels, so there's a direct space between them. That's how your material starts acting from an electronic point of view. And again, we'll try and go into more detail in another video to fully explain that. We also have the different ways that nanostructures can be made. So at the moment, if we want to make something smaller, but still on the macro scale, we can use machining processes such as etching or grinding to make it down. And we can make nanostructures in that way. However, we can also approach nanostructures from another way, and use atom manipulations and molecule manipulations to actually build the structures from on an atom by atom basis. And again, this leads to a whole another area of technology. And another thing we have to consider with nanotechnology, which I covered briefly in that other video, is once we start getting less than 100 nanometers, we're into the realms of the size of a virus and things that can easily move around the human body and transport themselves into human cells. So we've got this whole range of things which can be either used for good or for bad, where we can put stuff into a human cell. So if you think of a drug delivery, we can encase a quantity of drug into a nano cage, which can then go around the body and be pulled into certain cells and get very efficient drug delivery to specific areas. So there is all this we have to try to consider. So this is really why nanotechnology has its own field.